Good afternoon, everybody. My name is Jan Labohi. I'm CEO of World from Space, and I would like to welcome you at our first webinar from a webinar series about regenerative agriculture. Today, we will be speaking about how satellites are bringing benefits to regenerative agriculture, what is it, regenerative agriculture, and how we can actually increase the soil health and the productivity of fields at the same time. This webinar will last about 30 to 45 minutes, depending on your questions or your involvement. So at any time, feel free to write a message to the chat if something is not clear, if you have any idea, or if you would like to point out something that is interesting. This webinar is also being recorded, so you will be able to get into the recording later on, so you can focus on it and you don't need to take some special notes. What is waiting for us? The agenda, at first, I would like to introduce you to World from Space, the company, which is standing behind the Dynacrop product and behind this movement supporting regenerative agriculture. We will then look at what actually is regenerative agriculture and the actual use cases from a farming environment that we can support. This webinar is meant as an introduction of a long-term process. We're already working in regenerative agriculture, but at the moment we're looking for some companies that will be able to co-design the products with us, because we believe that it's not just about technical companies coming up with the great inventions using modern technologies, but it's about synergies, about involvement of different companies and different users from whole value chain of the food production that can really make a difference. And this is something that we would like to start with this webinar series. So firstly, briefly about us, the World from Space. We are a satellite data analyst company from Brno, Czech Republic, from the region of Brno, which is quite famous for IT and space technologies. The company is 5 years old with 12 people, so it's not super small, but it's also not super large. We say it's the right amount of people to make a difference, but easily changing the direction and focus on what is really important. Our key aim is to really help other companies in agriculture to use satellite data, because we believe and we see that it's making change, it's increasing production, it's reducing environmental impact, and it's giving information for informed decision making across the food value chain production, which today is very important. We have the problems caused in the value chain and in the supply chain. We need to really understand how the food production is going on and what can we expect in upcoming months in order to prevent food shortages or high increases in prices in food. We are working with the companies, but also working on research and development projects with the European Space Agency, for example, or local agriculture universities and big farmers in the Czech Republic. We're also providing consulting services to EUSPA, the EU Space Agency. And this webinar is taking place also with the help of the eShape project, which is a Horizon 2020 research project focused on co-designing and developing future products based on Earth observation data, based on satellite data. It's a really big project with around 50 partners working on supporting various sustainable development goals, in our case, mostly the agriculture related, and also supporting the Paris Climate Agreement and the climate change activities. I welcome you to check the eShape web pages. There's also a new nice video that you can see. And that's the introduction from my side. And as I can see that there are around 20 people attending the webinar, I would also like to see something about you. We have this tool called Mentimeter that we can use. I will try to get there now. It's very easy. You just take your mobile phone, or you can type into your web browser into a different window the webpage menti.com and this enter code, or you just scan the QR code which is on the right side, and it will get you directly into the web page where you can see the questions. So I kindly ask you to go to menti.com or scan the QR code so we can see. We will ask you some questions so we know who is taking part in the webinar. It's very important for us that you are also involved in what is going on, because this is part of the co-designing of the future activities. So you can type menti.com and the entry code, or use the QR code. This will be also visible on when I ask the questions, so you don't necessarily be scared that you missed it. You can still join us. But I will already ask the first question, which is who do you represent on this workshop? So please answer one of the possible answers. So although this webinar was planned for farmers, we can see that mostly it's about satellite data companies or others. Others can also be somebody from the value chain. What means that there might be more technical questions, because if we don't really have the farmers involved, we can really get deeper into the technical solutions. So we have 7 others, which means that the next time we need to divide it in a different way, because this definitely doesn't represent the majority of people. Good. Let's get more into the topic of the regenerative agriculture. Now, please type some words that come to your mind when you hear actually this connection, regenerative agriculture. What does it relate to? What ideas are there? What is on your mind? So it looks like that sustainability is really the keyword, which is mostly represented, but we have also soil health, long-term focus, accurate results. It's important that it's a whole system. It's innovative. There's also focus on biodiversity, carbon, and on long term. Yes. I think this represents pretty well what the overall understanding of regenerative agriculture is, and we can focus on it more. So this is it. You can still ask a question here now about what is the most interesting thing that you would like to know today, because you devoted some time to this webinar, and I would really like to answer your questions instead of talking about some things that I perceive as important. So if you have any questions at this moment, you can type it in, and we will see if I can answer it today, or maybe tell you that it's for some other part of the webinar series, because we will still have 4 more webinars after this one. I can see that nobody is typing the questions, so feel free to type them into the chat whenever it comes to your mind, and I will switch back to the presentation. Oh, we had one question here. Will you focus on the analysis of regenerative practices or support throughout the season? Yes, this is definitely something that we will discuss. If it's ongoing support or if it's just backwards analysis. So let's get into the topic. What are the 4 problems that we see at the agriculture today, perceived from the farmer's perspective? The first one, and the most obvious one in these days, is fertilizer prices, because the price of fertilizer went up almost twofold. It's almost at the all-time high price, and it's making a difference. While 2 years ago, farmers were saying that fertilizers, they use it, it's not really a big cost, and optimizing the use of fertilizers is something nice to have. Today, they perceive it as a big problem, and they start thinking about how to optimize the fertilizer use, because the prices of inputs, of energy, of fuel went up really significantly. So now it makes a big piece of a farm's economy. In the EU environment, there is still the highest share of the revenues coming from the subsidies, but even though the fertilizers can make a big difference. The second key problem we see is the time of agronomists, or the people who have the most know-how on the farm. The farms are getting bigger, and during the season, the agronomists really need to do a lot of decision and don't really have time to see all the fields every day. And for this, they need to have some kind of system or tools that help them to really make good decisions on time, because they're in a huge time pressure, and there is also a lack of people with know-how in agriculture, especially if we are talking about the new farming practices like regenerative agriculture, but also organic farming. Although it's quite it's not really new. There are not that many people who would be able to do organic farming on a larger scale and manage other people. The third problem, as perceived by the farmers, is currently climate change. Although they wouldn't call it climate change, it's mostly about weather patterns and the seasons. The seasons are now starting quite differently. It can be 4 weeks sooner than usual. It can be 4 weeks later than usual, which makes like a 3 months time window when the season can start. And then most of the farming practices are related to the start of the season and to the growing possibility of the plants during the season. Because if the season starts soon, but then there is a cold weather and no precipitation, the applications and all the practices must happen in a different way than if the season starts late and then it's suddenly really warm and there is a lot of rain coming. So the changes in the weather, which is quite unstable and unpredictable, are now causing problems in the management. The farmers really need to focus on what is the actual crop growth, what is the actual crop state, what is the current phenology, because visiting the field once a week is not enough anymore. There really needs to be some information more often. And the last key problem is the soil degradation. And that's the key problem for the regenerative practices. Because for many years, since 1960s and the Green Revolution, the soil is being really depleted. It's being overexploited, which means that more nutrients, more organic matter is used and disappearing than it's supported. So overall, the soil productivity is reducing for decades, and the activities and practices of farming are still set up in a way that are focusing and supporting the soil degradation. To reverse this, there are new practices that are mostly called regenerative agriculture, and we will talk about them very soon. How to solve all this problem together? We think that there is actually a good way how to do it, and it's called digital agriculture. It's mostly about integration of different technologies and different know-how that is already there. It's not about inventing new things overall, but about making use of them in synergies. Because today we have drones, we have satellites, we have IoT sensors, we have people that are going throughout the fields. But if you use only one or two of these technologies, you are not able to really understand the bigger and overall picture. So we believe that there must be integration of a lot of technologies together. And we, as Dynacrop, we want to be this satellite puzzle piece. We don't say that satellites can solve all of these problems. There are. We need to solve them all together. But we would like to support, with the satellite data, solving of these issues. Just a very brief introduction of how the satellite works. I don't think it's really necessary based on who is taking part in the webinar, but we have let's say passive satellites, which are mostly seeing the reflected sunlight. What does it mean? If a sun is shining on the crop in the field, the crop is absorbing some part of the solar radiation and some part is transmitted back to the space. And this part, which is transmitted back to the space, can be observed by a satellite. And because we know which part of the sunlight was consumed by the plant, we can do some estimation on the plant health, plant growth, or the other parameters of soil or water content. We have also active satellites, like radar satellites, that are sending signal to Earth, and this is a radar signal. This is being reflected back from the Earth, and based on the nature of the reflection, we can, for example, see the granularity of the field or the water content in the field. And this is something that we focus on in Dynacrop to help companies that don't understand satellites but understand agriculture to use satellites for their purposes. For this, we have a product called Dynacrop. What is it actually doing? It allows the agronomist or the users in the end to monitor the crop health. So to see how the crop is evolving, how much water is in the leaves, how much chlorophyll is there, how much water is on the fields. In now or in the past, because we use also the archive satellite data, it gives the field statistics. So different statistics on productivity zones, on crop development, the areas as data. The system also provides application maps for those who want to do precision agriculture practices like variable fertilizing or variable seeding, or focusing on variable soil sampling. The system provides maps that are used for the applications by machinery. And soil moisture. The system also measures soil moisture, so it gives information about the water availability in soil. I will just show you briefly how it works, and then we will go to the extension to the regenerative agriculture. So this is the demonstration environment of our system called Dynacrop. I will show you one example field, which is in South Moravia. It's this one. And now you can see the NDVI, which is the vegetation index, showing the density of vegetation in the field. The data is from yesterday, as you can see, and there is a variability in the field. You can see that some parts of the field has higher values than other parts. The system also allows you to look into the past, so you can see how it was during the last season, or prepare this zoning maps based on the current state, or we can look from 2018 until now, and create a productivity zone map, which is then used for variable fertilizing, for example. So this is the system as it is now. It's being used mostly with the farm management software companies produce some kind of software for agriculture. But we want to develop it further, and we really want to focus on the regenerative agriculture practices. So let's get started in regenerative agriculture. I think that most of you are familiar with organic agriculture. It's a movement or a type of farming practices that are trying to use more mechanical power and less chemical inputs. There are certifications for organic farming, which tells you what kind of practices you are supposed to do and what kind of practices are forbidden. For regenerative agriculture, this is not true. The regenerative agriculture movement is still quite wide, and it puts together people who really believe that the healthy soil is the key for the future. So currently, it's not a movement that would tell you the 5 things you have to do and 5 things you can't do, but there are still some ideas, some generally shared ideas of what is necessary to do if you want to increase the soil health and regenerate the soil health. The first one, it's focused on the organic matter, especially the soil organic carbon, and the organic matter is the key part of the soil that is guaranteeing productivity. It's also an indicator of the productivity, and for example, the availability of soil worms that is there, and their number is used as an indicator of a healthy soil. So one of the practices that is there is focusing on really trying to put more organic matter into the soil and support the internal soil biodiversity. The second one is CO2. Currently, most of the farming practices are producing CO2, carbon dioxide. So it means that they are actually supporting or enforcing climate change. But the key vision for the future is that soil should be a carbon sink, which means more carbon should stay after the season in the soil than it was in the previous time. The regenerative farming practices today thinks that around 1 ton of CO2 could be really sequestrated, put into the soil every year based on the regenerative farming practices. So it means that the farmer is actually getting the CO2 from the air and putting it into the soil. Supporting the organic matter in the soil and also increasing the amount of carbon is directly connected to the water holding capacity of the soil. In many parts of Europe, also the world, there is a problem that the holding capacity of the soil is decreasing, which means that after the rain, the soil is not able to infiltrate as much water as it could, which then, if there is a period without rain, means that there is no water available for the plants. Improving the water holding capacity then means that there is more water available at the time when it's necessary, and it's also reducing possibilities of floods. It's also reducing the transfer of nitrogen from fertilizer into the water bodies, because if the water stays in the soil, then also the fertilizer stays there. And overall, these things are aiming to build crop resilience. Today, a lot of crops are supported with multiple pesticides and other substances that increases the resilience or kills the enemies of the plants. But by nature, a field which is in which is in the area of high biodiversity is having enough organic matter, is in the place where there is a good water holding capacity, this is also a resilient field. So supporting the crop resilience, the natural one, is like the fourth key thing of the regenerative agriculture practices. This is the sector as itself, but how can we how it's done like in real? What can the farmer do to support regenerative agriculture or to move in the direction to regenerative agriculture? Because, as I said, it's not some already defined thing. So there are basically four ways how to do it. The first one is focusing on the crop that the farmer is planting. In Europe, it's quite common to have a crop rotation, which means that each year you plant something different on a field, but it's not always. There are some areas that focus really on corn and that they can plant corn every year for 5, 10, 20 years, which is really degrading the soil. Whereas if you set up a good crop rotation, which means that you really switch the different types of crops that support the different ways of microbes and different soil content, then you can then you start regenerating the soil, and you're also regulating the inputs and outputs of some substances. So that's crop rotation, and it's also connected to cover crops because leaving the soil bare is causing a big trouble, because if the soil is bare, it can be easily not destroyed, but endangered by erosion from water or from wind. Also, the sunshine is if there is a lot of sunshine, it's killing the organic matter which is on the top layer. So having a cover crop, it means planting another crop after the main one during the season. So trying to focus on really having all the time something growing on the field. It's another regenerative practice which is quite common. The other one is focusing on tillage. So currently there is quite high tillage going on. Some regenerative farming practices are focusing on lower tillage, which means that you're trying to till the field as less as possible, maybe in lower depths and low often. Or there is also a movement on no tillage that is really focusing on stopping the tillage at all, and working on other practices that are supporting the soil in receiving the nutrients and changing the content, mixing up the content, for example, with the cover crops. We don't say which is better. It's definitely something that is very specific to each field, but lowering the tillage is really helping the retention of water, is helping to ingest the crop residues, and has a long-term positive effect on the soil health. The third thing that the farmers are doing to support regenerative practices is using organic fertilizers, so mostly compost and manure, because this really is closing the loop. Because if the plant is eaten by the animals, then from the animals the rests go back to the soil, and it's really the circular agriculture. And similar with the organic waste becoming compost and getting back to the farms. Here's the problem, of course, is the availability of compost and manure in the larger volumes. If the farm is doing integrated production, which means they produce both crop and both livestock, then it's easier. But buying compost or manure is very difficult, and spreading is also not that easy. So there is some optimization necessary for this. And the last one, last practice is focusing on planting multiple crops on a field, or even combining forestry and agriculture, which means that you're using trees that are providing also shadow. They also provide some, for example, wind barrier. They provide other services to crop. You have crop in the middle lines that are as wide that your machinery can get through. And this overall is really increasing the crop resilience. So you don't need to use that many pesticides or other applications during the season. So this would be the 4 practices how the farmers can implement the regenerative agriculture. And now let's look at the use cases, how the satellites can actually support this, because that's the key output of this webinar. So the first one is the carbon content monitoring. So it's a service that is helping farmers to understand how much soil organic carbon is on their fields. The other thing is a variable organic fertilizing. So using the organic fertilizers in a variable way, not giving the same amount to all parts of the field. The next is field sampling planning. It's for the farmers that are using soil sampling for understanding the composition of the soils and the development. It's monitoring of soil water content. And we have also some cover crop and tillage detection here mentioned, but this will be mostly during the next webinars. We will not get into the detail in this one. But let's start. So what can satellites do with regenerative agriculture or carbon farming? Here's also the other term called carbon farming, which we might step for a while, because carbon farming is another concept focusing on putting the carbon into the soil and getting the money for it. It's quite a big thing because it can help farmers to get new income of money for implementing regenerative farming practices. At the moment, farmers not really subsidized to focus on the soil health, but this system can really help them to get some additional income for the additional work they have with the regenerative farming. But let's see the examples. So this is the example of soil organic carbon monitoring from a satellite. When the soil is bare, you are able to estimate the soil organic carbon content. And if you look on this during multiple years, you're able to set up if there is some trend or not. Here on the left, you can see the soil organic carbon index in the field, and in the right, you have the production zones in the field. So the green zones are high productivity zones. The red zone is the low productivity zone. As you can see here in this field, it's quite matching, which means that the lower soil organic content is in the same place where there is the lower productivity zones. But overall, this is important for the farmer in order to understand what is the current situation there. For those that don't want to just see how it is, but want to get really the on-hand information and the detailed information, it's there is this good fusion between the satellite data and soil sampling. So if you want to really have precise number, you need to have a soil sample, which means go to the field, get the sample and send it to the lab to get the analysis. But to do it for all fields every year, it's very costly, especially if you use some typical grid system, which means that for each 100 to 100 meters, you get the sample, or if for each kilometer to kilometer, you get a sample. So for this, we are supporting the farmers in setting up the places where to do the sampling. It's based on understanding the zones. So we divide the field into the zones with a similar soil organic carbon content, and then we select a point which represents the zone. So as you can see here on the right picture, you have six samples per this field, and these samples will really represent the zones. So in the random approach, you would need to have around 20 or 30 samples for this field in order to get the really representative information. Here we have the example for the supporting of variable organic fertilizing. This is for a special use case when you want to really get the organic fertilizer. Usually, this is, for example, before potatoes. If there are potatoes in the crop rotation, then you do it before the potatoes, which is this example. And for creating the variable map for applying the fertilizer, we are using the productivity zones, which is the map on the left, based on analysis of 4 years of the field. So how the field is performing, what are the average productivity zones there, and the combination with the takeoff of the nutrients from the last season. This is the map, which is mapping during the last year, where was the higher intake of the nutrients and where was the lower intake of the nutrients. And then we have a specific formula, a little magic that puts this together, and this map is then used by the farmer that wants to use the variable rate optimization of organic fertilizer. So then he has this map, and this can be transferred to tractor and then used for fertilizing. Another use case is for the irrigation. So for the satellite data, we can also see the water content in a different ways. This is an example of a typical round field with the irrigation system. On the left, you have the situation before the irrigation, and on the right, you have the situation after the irrigation was started. But as you can see, the irrigation system doesn't really work here. It's mostly putting water out on the outskirts and not really in the middle part of the field, which is usually some problem with the sprinklers happening. So this is one of the way how to monitor irrigation. The other way is to monitor the water content in the soil. For this, we use the radar satellites, and you see how the change is happening throughout the year. And there is some graph from the validation. You can see if there's not enough rain in the beginning of the season, the index goes down, but then if there is a lot of rain, the index goes up. So it basically gives the farmer information about how much water is there at the moment, and this is, for example, used in the seeding planning. The last thing that can be observed with the satellite is for practices where you need water in the fields. This is specifically for rice fields in Italy, where you need to monitor how long the water is there, because this has also the impact on the soil quality, on how long the water is there and how much it flows, how much of the content it takes together when it's again gone. So this is a use case from the Italy's rice fields. Those were the use cases. I can see that my presentation was longer than I expected it, but that's it at the moment. And I will check the chat. What kind of questions? There are no questions. So I open the floor now for the questions. Please type them into the chat. And this is not just about asking questions, but as I was saying, we plan this as a co-design activity, which means that we invite you to take part in the process of creating this product. I was showing you some examples of what we already do, what we can do, but we are very interested in what you think that is the necessary part. What should be implemented in the system in order to get really the high adoption by the sector and to really change the nature of the agriculture. So there are still no questions. I give you still some time to type it. But if not, then don't worry, you can also send the questions by email, or you can ask me to organize a meeting together where we can discuss directly with you. What do you see that is happening in the sector? What are the needs that you would like to address? Somebody is telling me that there are questions on Menti. Thank you for this. There is this question. I forgot about it. So focus support throughout the season. Yes, we think that it's important if we are talking about farmers today, the support throughout the season, because switching to regenerative farming practices is making life more difficult for farmers. So we really want to get the information at the time when it's necessary. Today, this is quite disturbed by the cloud coverage when we are talking about the satellite data. So that's why we're working also on the fusion index of multispectral and radar satellites, which will mean that the farmers will get the information about state of their fields basically every 2 or 3 days. So they will get really the information at the time when they need it, not at the time when it's available by satellite. The other question is how satellites will help to analysis farming. Yes, so if I understand correctly, this question is about overall analysis of the farming practices. So this is something that we will address in the other webinars, because we know that some regenerative agriculture is becoming quite hot topic. Some people want to buy food from the regenerative agriculture, but who is there to say if these practices are regenerative or not? So we can see that there is a need for a tool that will analyze the farming practices and tell if there are regenerative farming practices happening. For example, if the cover crop is there every year or for how long, if there is the tillage happening often on the fields and others. So this is all possible to get this information from a satellite, and we want to make the system in a way that it will provide the analysis of the farming practices. If the question was meant differently, feel free to send me an email and we can discuss it later. How do you calculate soil moisture and what is the spatial and temporal resolution? Very good question. So we calculate soil moisture. I was showing you different use cases. For each of the use cases, it's calculated differently. But basically, there are 2 ways how we do it. The first one is we use Sentinel-1 imagery, which has a temporal resolution of 2 to 3 days in Europe when there are 2 satellites. Now, one of the satellites is not working at the moment, sadly, so it means that the temporal resolution is about 6 days. The spatial resolution differs on the use cases. Basically, it's working very good on a field level. For some long-term analysis, it's working good in 100 meters resolution, pixel size. We are also trying to get to the resolution of 10 meters, but this is not working properly at this stage. The second way how to calculate soil moisture is from the multispectral satellite Sentinel-2. There are different biophysical parameters and soil moisture related indices that we calculate. This is in 10 meters resolution mostly, and the temporal resolution is 5 to 7 days in Europe. Yes, following regenerative agriculture, how much CO2 is estimated to be possible to store in 1 hectare of cornfield after the season? What is the value in terms of money on carbon trade market? Yes, so it's estimated that on each hectare it could be 1 ton of carbon stored each year. So I don't know a specific number on the cornfield, but there shouldn't be anything like a cornfield in the future. There should be only the field that has corn as part of the crop rotation, which is usually 5 or 7 different crops that are going one by one. So let's say 1 ton of CO2 per hectare. And in terms of value on the carbon trade market, currently the price of CO2 credit for the emission trading scheme in the European Union is about 80 euros per ton. This price is quite volatile, but now it's around 80, and it's estimated that it will be somewhere between 50 and 300 euros in the upcoming 5 years. So if we have a field of, let's say, 20 hectares, this means that around 1,600 euros can be earned with the credits that are generated. This is when we count the price of the emission trading scheme. On the other hand, currently there are a lot of companies who want to offset their carbon emissions, and they look for ways how to offset it. The typical way is investment in some renewable energy products, like building solar power plants, wind power plants, or planting trees products. But more and more companies are really now looking at buying the credits from the regenerative agriculture. So the value here is much higher, and it can be between 100 and 200 euros per ton of CO2. So then the additional money for the farmer can be higher. The problem here, of course, is the certification methods, how to really precisely say how much carbon was stored in the field. This must be done with the soil sampling at the moment. There are a lot of companies that are trying to make this analysis from satellites, but we are quite I think this is not really possible to do with the current generation of satellites. Before we will have the multispectral satellites and the new constellations in 5 to 10 years, then there might be some also satellite-based certification scheme. But before that, the satellites will be used mostly for supporting these activities. Do you feel that the accuracy of your current satellites and imagery is good enough to provide real numbers for growers to use to sell carbon credits, or is there still some need for improvements? Yes, so this is related to the previous question. No, we don't think it's good enough to provide real numbers, but it's good enough to optimize the sampling, soil sampling for understanding the real values, because only the soil sampling can provide the real numbers that you are asking that can be then used for the carbon credits. Because with the multispectral and radar satellites, you are not able to get the enough precision, even while using the deep learning and other high-tech new methods. These systems are very useful, and they can have higher accuracy on small scale, like not even regional one, but if the system should be working on a European level, then there is no one that we see around that is really having a system which has the accuracy that would match. If corn is just one of 7 crop types in rotation, does it mean every year 1 ton is stored following regenerative agriculture on that 1 hectare of field? Yes, this means that every year 1 ton can be stored on 1 hectare of field. It will be more with some crops, it will be less with some crops, but this is just the easy average number that is coming from one research paper. I'm not saying it's 100% right, but this is what the research is showing as an indicative number. This will definitely be different in Nordic countries, in Central Europe, and in Mediterranean countries. The state of soil at the beginning will be the key thing. Like if there is very exploited soil and or very fertile soil, then the difference is very big. We have some other questions in chat, so I will go through them as well. Do you see drone data for smaller parcels when satellite imagery are not enough precise, for example, zones estimations? Yes, this is something that we don't do as a company, but we see that our clients or our partners are doing this. So they use satellite imagery for the first zone estimation, and if the farmer wants to have it more precise, they then use the drone data in order to make it with higher resolution when this makes sense for the application. So drones and satellites are really good together. There is a technical question for the counting of the soil moisture index, which I'm not able to answer, but I would like to invite Milos to send me an email, and we can discuss this also with our technical experts. Another question, do you have in-situ soil moisture data which you can use for calibration? Yes, we have. We use soil moisture data from different countries and also on a large scale in the Czech Republic, but also in Germany, Spain, Portugal. And there was some, I think Bulgaria was there as well, and that is used for validation and calibration. Another question. The advantage of satellite data is regular revisit, thanks to which we can observe changes in time and create composites as handy application maps. Drones, nice detailed information, but only one-time slice. Yes, this is what we say. That this is really about the synergy of the two technologies. We can get the information from satellite on a long term, and when it's necessary, for example, for identification of the plants that the weeds, for the weeds detection, you cannot get the weed detection from a satellite, but the drone is perfect, and you can really optimize, reduce the number of the pesticides application by 80% if you use the drones for identify weeds, and then also for the variable application. By observing satellite data, will you apply fertilizer or irrigation or other practices? Yes, so the application maps that are based on the satellite data are currently most for fertilizing or application of plant growth regulators or application or variable seeding rates. For irrigation, it's being also used. There are also companies that provide even the irrigation prescriptions, which says how many liters of water should go to which parts of the field. This is something that we are not providing at the moment, but is definitely technically possible if there is an interest. So the maps that we provide are good to understand the intrafield variability, and that's the key of the precision agriculture, to treat the different zones of the field differently because they have different needs. And it's not necessary, it doesn't matter if it's fertilizer or irrigation or any other inputs. It's about being able to make the difference. I can see that Damian already answered the question about the SME, that we're using Sigma. Can you please share any publication article about where I can read? Yes, I can share some list of the articles that we are using. I will put it on the workshop page on our webpage, dynacrop.space, so you will find it there also with the recording of this webinar. This is not a question. This is also a question, but we have one last question on the Mentimeter. And it's, are there any common metrics that measure positive sides of regenerative agriculture? Yeah, so that's that's a very good question. There are common metrics, but there are not metrics that would be spread everywhere. So there are some specific ones that are used in US. There are some specific ones that are used in Europe. Also, it's different if we are talking about the crop production, or for example, for the places for regenerative practices in grazing, livestock or sheep. So for each of these, there are different metrics. And I think this is something we need to discuss more detailed, because this question is more general, and answers would take another hour to get to. So I think we reached the end. Thank you for your questions and your participation. Thank you for taking part in the webinar. We have still 4 webinars to go, where we will focus on other perspectives of the regenerative agriculture from different users. On Thursday, we will talk about carbon credit traders. We will talk about the fruit production companies on June 7, about food tracing on June 8, and we will make a summary webinar on June 16. So thank you for your time and participation, and I hope to see you again at the other webinars. This is me. My name is Jan Labohy. I'm from Dynacrop, and I'm looking forward for you to get in touch with me and discuss the special things you need or you think that are good for the future of regenerative agriculture. So thank you and goodbye.